Okay, so our next topic is heat exchanger effectiveness. So this is parang epsilon yung kanyang symbol, So by definition, heat exchanger effectiveness E is the ratio of the actual rate of heat transfer to maximum heat transfer rate if the heat transfer has an infinite area. No? Okay? So imagine niyo yung heat exchanger effectiveness, ratio siya ng actual heat transfer divided by the maximum possible heat transfer rate. Kaya 'di ba effectiveness, para siyang efficacy, 'di ba? Naririnig 'yan sa mga bakuna, Parang 'di ba pag 100% efficacy, ibig sabihin pag tinuruan ka ng bakuna na 'yon, hindi ka na magkaka-COVID, Ito naman, yung efficacy kasi pag sa laboratorio, So pag sinabi namang vaccine effectiveness or vaccine effectivity, ano naman 'yon sa field na. So halimbawa tinurukan kung sino man turukan ng bakuna na 'yon, for sure hindi siya pag 100% for sure hindi siya magkaka-COVID. Ganun. So ganun din to. Ganun din tong effectiveness. Yung ratio ng actual divided by sa maximum possible. Okay? So ano bang application nitong concept na to? So in most instances, ang given lang yung initial temperature lang. Tapos yung heat exchanger area, kasi nabawa, given yung heat exchanger. Tapos given yung overall heat transfer coefficient yung U sub O. Imagine nyo ba? Halimbawa meron yung heat exchanger, nandiyan yan. Tapos magraran kayo ng dalawang stream. Usually ang given doon sa dalawang stream, yung flow rate nila, yung specific heat nung bawat substance, at saka yung initial temperature. So, syempre, we wanted to predict kung ano yung magiging final temperature. So, in predicting the final temperature, ginagamitan natin ng effectiveness, heat exchanger effectiveness concept. Okay? This is used to predict the final temperature. Na-imagine nyo yung application niya? Okay. Anyway, basahin nyo na lang ulit kung hindi nyo ma-imagine. Tsaka makikita nyo naman mamaya sa problem. So, meron naman tayong mga illustrative problem before we proceed to the actual problem. So, this is the general equation. Q is the actual heat transfer. Q. Oops, sorry. This is the actual heat transfer rate. Okay? So parang sa Q dot yan, sa thermo. Yung E, yung effectiveness. Ito yun. Yung C minimum, that's your heat capacity. Basically, this is C minimum quantity THI minus TCI. This is the maximum, This part of the equation here, this is the maximum heat transfer. Of course, yung C min, that's your minimum heat capacity. Okay. So ang C or heat capacity is generally equal sa m dot times this is S is specific heat. So m dot mass flow rate. Tapos yung S is your specific heat. Tandaan nyo pa sa thermo. So generally ang heat capacity, ang unit niyan, halimbawa kilojoules per Kelvin. Ganon, amount of heat per unit of temperature. Kasi halimbawa to, multiply niyo halimbawa ang kilogram per second, tapos yung specific heat halimbawa kilojoules per kilogram per Kelvin. So magka-cancel to, kilojoules per second per Kelvin. Ganun yung unit ng heat capacity. So any question? So I hope you see that the A is the ratio of the actual heat transfer dun sa maximum heat transfer. THI, what is THI? Ito yung initial temperature na mataas, no? Initial high temp. Halimbawa, merong you can consider the cooling stream, no? Yung cooling stream, di ba pagpasok niya, mataas yung temperature niya. So yun, yung pumapasok na yung temperature ng pumapasok na cooling stream, yung lumalamig, yun yung THI. Okay? And then yung TCI naman, yung pumapasok na mababang temperature ng isang stream, ng heating stream. So, syempre THI minus TCI, palaging positive itong dalawa, no? Palaging positive itong maximum heat transfer. Parang yung E natin maging positive. Okay, do you get what I'm trying to say? Okay, so let's try to do the exercise para mas ma-imagine. Paki-mute, Mr. Hindi ko makontrol eh. Mr. Paki-mute ng mga Paolo, Paseren. Naka-open ng mic mo, hindi ko siya makontrol. Mute na. Thank you. Oil flowing at a rate of 5 kg per second, and then the CP or the specific heat of this oil is 2.09 kilojoules per kilogram per Kelvin, is cooled in a counterflow heat exchanger from 366.5 Kelvin to 344.3 Kelvin by 2.0 kilogram per second of water. So the specific heat of water is given to be 4.18 kilojoules per kilogram per Kelvin, entering at 283 Kelvin. The overall heat transfer coefficient Q sub O is 340 watts per meter squared per Kelvin. Calculate the effectiveness of the exchanger. So basically analyze nyo lamang, draw nyo lamang yung heat exchanger, draw nyo lang versus step drawing. So ito halimbawa yung oil natin, no, pumapasok siya ng 366.5. Tapos paglabas niya 344.3 na. Okay? Tapos yun namang water, okay? Pumapasok siya ng 283. Okay. So to calculate E, di ba ang formula natin ng E ay Q divided by Q max. No? So ang Q, you can easily get yung Q from the equation m dot Cp delta T. So given naman yung Cp ng oil, it's 2.09, tapos yung kanyang m dot ay 5.0. Tapos ito yung pressure, ito yung temperature niya, 366.5 tsaka 344.3. So you can easily solve Q. Yung Q max naman, so pag halimbawa you have maximum area or you have infinite area dito sa heat exchanger, yung pumapasok na water ng 283, ang mangyayari niyan kung malaking-malaki yung area ng heat exchanger, paglabas niyan 366.5 na rin. No? So ang maximum heat, consider nyo lamang yung CP ng water at saka yung flow rate ng water, tapos ito yung maging temperature. So ganun lamang, ganun lamang yung i-assume nyo lang na yung water yung temperature niya equal sa temperature ng pumapasok na oil. Okay? This is your water. You get it? So in order to calculate E, this is simply MCP delta T ng oil. So M dot ng oil is 5.0 kilogram per second. Tapos specific heat ng oil 2.09 kilojoules per kilogram per Kelvin. Tapos yung kanyang temperature, yung mataas ng temperature is 366.5 minus 344.3. Palaging positive, palaging yung mataas yung iuunahin yung temperature. These are in Kelvin, so magka-cancel out lamang to. And then also the kilogram will cancel out. So kita nyo, the unit is kilojoules per second. Yung sa ilalim niya, yung Qmax, ganun din. So your water is flowing at 2.0 kilogram per second. Tapos, ang CP ng water is specific heat, 4.18 kilojoules per kilogram Kelvin. Okay? Tapos, we assume, no, na maximum yung temperature na possible sa water, so 366.5 din, and then initially 283 lang siya. So this is how you calculate effectiveness, no? Heat exchanger effectiveness on this problem. Do you have any question? Nakita niyo yung concept kung paano? Just ulitin niyo lang sa calculator. Yun, you're supposed to get ilan? Very good, Paolo Masura. Ano? 0.32. Any question regarding this illustrative problem? So if you don't have any question, let's proceed. Okay. So, na-observe nyo dun sa huling problem, actually binigay natin yung isang final temperature. That's why we are able to calculate the effectiveness without using an equation like this one. Ano? So, medyo mahaba kasi yung derivation. Ano? If you're interested sa derivation ng equation na to, you can find in Gene Copley's. Pag diniderive ko to eh. Malaki yung board, kaya lang limited kasi yung board sa sa Zoom, ano? So, anyway, so just tanggapin niyo na lang muna na ito yung general equation for effectiveness, ano? So as long as you have the heat capacity ng dalawang stream, Cmin at saka Cmax, you can calculate the 1 minus Cmin divided by Cmax term. Tapos, generally, kung available naman yung heat exchanger, usually given din yung kanyang U, yung kanyang overall heat transfer coefficient, tsaka yung area. So, with this, you can calculate the effectiveness or E. Now, with this equation. So, pag na-calculate nyo yung E, tapos, alam nyo yung maximum, you can calculate the maximum heat transfer, you can predict the actual heat transfer. Pag na-predict nyo yung actual heat transfer, you can predict the final temperature. Remember, ang application ng heat exchanger effectiveness is for predicting the final temperature. Given yung streams, no? Yung flow rate, yung specific heat, yung initial temperature, at saka yung UO, at saka yung A ng problem, you should be able to predict the final temperature. Okay? Tapos we have another definition right here, no? The number of transfer units. The number of transfer unit is defined as U times A divided by C minimum. No? So pag sinabing number of transfer unit, basically ang concept nito is parang average average temperature. Kasi 'di ba ang pag heat exchange, pag merong heat transfer, ang driving force yan ay temperature. So parang ito yung average temperature per unit average temperature range, parang gano'n yan, kung ilan yung transfer unit. Okay, anyway, basta ito yung formula niya, UA divided by C minimum. Parang yan, di ba, you have, pag dinivide nyo yung average approach, di ba, you know the temperature approach, tapos dinivide nyo siya ng average range, average temperature range, you're going to get the NTU. Ganito yung definition ng NTU. No? So you can also calculate NTU using this equation, UA divided by C minimum. So do you have any question regarding this equation? And of course, we also have some figures. I think this one is from the from the handbook, Hindi. This one is from Gene Copley's din. So, kung gusto niyo naman na mabilis, merong graphical way of determination of effectiveness, Pero syempre based din yan dun sa equation, So we have two figures here. The first one is for counterflow. This is for counterflow. This one is for parallel. So as long as you have the NTU, UA divided by C min, no? C minimum. Ito yon yung 1, 2, 3, 4, 5. Tapos you have or also calculated C min divided by C max. So hanapin nyo lamang dito, no? Yung value ng effectiveness. So mamaya gagamitin natin itong graphical method. Itong pangalawa ay sa parallel. Itong second na lang sa parallel to. Okay? Let's try a problem. Another problem. So the same problem actually. Oil flowing at 5 kg per second, CP is 2.09. Is cooled in a counterflow heat exchanger from 366.5 to 344.3 by 2 kg per second of water. CP min is 4.18, entering at 283. The overall heat transfer U sub O is 340. Calculate the number of transfer unit assuming F is equals to 1. So basically, pinapahanap dito yung UA divided by C minimum. F is, ito yung correction factor, sa shell and tube. Yung hinanap natin kanina sa problem. So there are two ways to solve this problem. Una, pwede nating gamitin yung equation, and the other one is pwede nyong kasi 'di ba UA, actually meron tayong U pero wala tayong A. So pag ginamit natin yung equation na Q is equals to F U times A times delta T LMTD. So kailangan nating ma-determine yung delta T LMTD para makuha natin yung UA. So probably kasi given naman yung dalawang temperature dito, you can assume na walang heat loss. So pag walang heat loss tapos yung F is equals to 1, you can calculate UA from this equation, di ba? So pag walang heat loss, you can calculate one of the final temperature, the last temperature. Tapos you can calculate delta T LMTD. Tapos alam din naman natin yung Q, so you can calculate UA. Tapos C minimum is 2.0 times 4.18. That's one way. So let's try to do that. So una, calculate muna natin yung final temperature ng water. So, assuming na walang heat loss, di ba? MCP delta T ng water plus MCP delta T ng oil, assuming walang heat loss, is equals to 0. So 5, kayo na lang maglagay ng unit para mabilis. 2.09. And then, ang final nito is 344.3. Pag delta T, di ba, final minus initial. 366.5. Okay? Plus, yung sa water is 2 times 4.18. And then, final temperature niya is X. Yun yung hinahanap natin, Tapos 283. Tapos equate natin sa 0. Negligible heat loss. So find X. Ito yung final temperature ng water. Ilan nakukuha niya? $310.7. Yes, very good. I also got 310.75. Very good on Paul. Okay, so with this, you can now calculate delta T LMTD. So drawing nyo lamang yung heat exchanger nyo para mabilis nyo makalculate yung delta T, yung mga approach. So 366.5, tapos 344.3, yung water dito 283, tapos lalabas siya ng 310.75. So ito, ang delta T nito ay 61.3 The other one is 55.75. Okay, so just calculate the delta T LMTD. So it would be 61.3 minus 55.75 divided by LN, 61.3 divided by 55.75. Yeah. 58.48, ano? Okay, remember, ang gusto nating makuha yung UA, ano? So Q, ang Q natin is this one. Itong 5 times 2.09 times 344.3 minus 366.5 divided by ito, itong 58.48. So that's UA. Are you still with me? So UA is 5 times 2.09, okay, times 344.3 minus 366.5. Anong unit nito? So yung 5 kilogram per second, this is 5 kilogram per second, tapos this is kilojoules per kilogram. So magka-cancel out ito, ano, yung kilogram na to. So you have kilojoules per second per Kelvin. Tapos this is Kelvin, so magka-cancel out din yung Kelvin. So ang magiging unit ay kilojoules. This is kilojoules per second. Ano? Can you follow? Tapos divide natin itong Kelvin. So 58.48. Okay, so ang UA natin is, and then finally, i-divide lang natin ng C minimum. Can you still follow? So I need to explain something. Gawin yung positive. So 366.5 minus 344.3 para maging positive. Palaging positive ang effectiveness. Ano? So baliktarin nyo to. Baliktarin nyo to. Or just make your answer positive. Sorry for the mistake. Yun, you're supposed to get 3.97, ano? Na U over A. This is kilojoules per second. Are you getting the same? Yeah. Tapos yun, divide na lang na C minimum to get, ano? Divide na lang to na C minimum to get the effective, the NTU, number of transfer unit. Kasi di ba NTU is UA divided by C minimum, ano? So C minimum is 2.0 kilogram per second, this one, times 4.18. So in order to get effectiveness, I'm going to clear this up kung wala naman kayong tanong. Wala kayong tanong so far? Do you have any question? Kasi wala na akong masulatan. So I'm going to clear this up. Yep, palaging positive pa ulit ang effectiveness. Okay. So ang NTU equal siya sa U times A divided by C minimum. So na-calculate natin ang U times A is 3.97, no? Kilojoules per second, di ba? Tapos ang kilojoules per second. Ang C minimum naman, ito, no? Ito yung 2 times 4.18. 2.0 kilogram per second, okay, times 4.18 kilojoules per kilogram per Kelvin. So, magka-cancel out. Dapat magka-cancel out lahat ng units. Ano? Wala dapat matitira. Dapat unit less yung NTU. Mag-divide tayo ng temperature, may Kelvin din to, ano? Kilojoules per, ang ano, U times A ay kilojoules per second per Kelvin. Do you have any questions? So, should be able to get NTU is equals to 3.97 divided by 2 divided by 4.82. Yun, you're supposed to get 0.47. Ano? Do you have any question regarding this calculation? Of course, you can also try to use this equation, no? And then try, halimbawa gawin niyo tong let x is equals to UA times C minimum. Ito, gawin niyo tong x. Tapos calculate niyo yung C min at saka C max substitute dito. Tapos di ba na-calculate naman natin yung value ng E. E is equals to 0.33. And then you can calculate UA divided by C min, or NTU is also the same as 0.47. Dito ba pwede rin? Di ba ano 0.33? So halimbawa dito counterflow. Kaya lang shell bagay. Pwede ba dito? Relatively medyo complicated pag dito, ano? Kasi pag 0.33, halimbawa dito, counter ba tayo? F is equals to 1. F is equals to 1, ibig sabihin shell and tube tayo. So pag shell and tube, pero F is equals to 1. Kasi ba dito? 0.47. 0.3. Oo. Ito rin yun, no? Di ba? 0.47 din. Ayan, no? Di ba? Yung 0.33, 0.47 din. No? Approximately the same answer. Di ba? 0.33 will give you approximately 0.47. Tama pala. Pag parallel, ayan, medyo sabog na siya. Ano, malaki na yung range niya. So, mas dito yan. 0.33. Nakita nyo? 0.33 tapos 0.47. Pwede rin graphical. Ano? Okay, so let's try to solve a standard problem. Example 4.9-2 from Jean Coplis. Water flowing at a rate of 0.667 kilogram per second enters a counter current heat exchanger at 308 Kelvin and is heated by an oil stream entering at 383 Kelvin at a rate of 2.85 kilogram per second. CP is equals to 1.89 kilojoules per kilogram per Kelvin. Yung mga naunang problem kasi illustrative problem lang yun, ano? Mga local problem lang, ini-illustrate lang niya yung definition ng effectiveness. Ito na yung actual. As you can see, ang given lamang ay yung mga initial temperatures. And then you have the U sub O, the overall U is 300 watts per meter squared per Kelvin, and the area A is equals to 15.0 meters squared. Calculate the heat transfer rate and the exit water temperature. No? So basically, for this problem, gagamitin natin yung effectiveness equation. Ano? Yung equation yung gamitin natin, yung E, yung mahaba. So ang una natin gagawin, calculate muna natin yung heat capacities. So halimbawa, seawater, heat capacity ng water, para ma-determine natin kung alin yung Cmin at saka yung Cmax. Yung mas mababa, yun yung Cmin, C minimum. Yung mas mataas yun yung Cmax. Ano? So ang halimbawa, ang water, ito, 0.667, ano? 0.667 kilogram per second. So siyempre, mag-assume tayo ng ng specific heat ng water, halimbawa 4.184, no? Kilojoules per kilogram per Kelvin. Magka-cancel to. So ang water ay 2.79, ano? Kilojoules per second per Kelvin. Yung sea oil, heat capacity ng oil. Yung oil naman, 1.89 ang kanyang CP, 2.85 kilogram per second. By the way, tandaan nyo naman ano, ang C, heat capacity M dot times specific heat or CP. No? So times, this is 2.85 kilogram per second. Ay, mali, 1.89 pala. Naduling ako, pasensya. This is kilogram per second, this is kilojoules per kilogram per Kelvin. Ano? Specific heat, kilojoules per kilogram. Okay lang? Hindi naman kayo nalito doon sa ano? Sa maling na isulat ko. So just multiply 2.85 times 1.89. So this is 5 point, mga 5.39, ano? 5.39. So alin yung Cmin? Alin yung Cmax? So mas mababa yung CH2O. So ito yung C minimum. Ito yung C oil, ito yung Cmax. Tapos, syempre calculate muna natin yung effectiveness. So ang formula natin ng effectiveness is, hindi ko rin memorize. Kayo kailangan yung i-memorize. So bawal magbukas ng PowerPoint sa exam. Hanapin nyo baka nasa handbook. So ang ginagawa ko, kinakalculate ko muna yung 1, kinakalculate ko muna yung 1 minus C min divided by C max. No? So, tsaka ako pinapasok dito sa equation ng effectiveness. So, 1 minus C minimum is 2.79. Pero kung gusto niya ipasok niyo diretso, wala namang problema. 5.39. As long as you got the correct final answer, no? 5.39. So itong C min over 1 minus C min divided by C max is 0.48, 23. pala. Tapos another thing na kinakalculate ko yung NTU. Yung NTU is yung UA divided by C minimum. So yun, 300. Kaya lang watts ito, ang unit natin kilowatts. So gawin natin itong 0.3 para kilowatts din siya per meter squared per Kelvin. Tapos times A. A natin is 15. Ito. Meter squared. Magkakancel yung meter squared. Tapos divided by C minimum. C minimum is this one, 2.79. Masusundan niyo pa? I'm just sharing how I calculate effectiveness. So, kung gusto niyo diretso niyo yung doon, mahaba nga lang yung equation, pero pwede rin yun. 0.3 times 15 divided by 2.79. 50 over 31, 1.61, Tapos calculate na natin yung A. So E is 1 minus E, tapos negative NTU 1.61, tapos times yung 1 minus C min C max 0.4824. Tapos sa denominator niya, you have 1 minus C min over C max. So that's 2.79 divided by 5.39. Okay. Masulatan. Tapos E times E raised to negative 1.61 times 0.4824. Mahaba lang kasi yung equation nitong E, ano? Pero the problem is relatively simple pag na-calculate nyo na yung E. You just pindutin nyo lang sa calculator. You're supposed to get E, ang value ng E ay 0.71. Do you have any question? Basically, gagamitin nyo lang yung mahabang equation ng E to calculate E, ano? As after determination of Cmin and Cmax. Tapos given naman yung U at saka yung A. Ganun lang naman yan. So after getting 0.71, you can actually calculate now the heat transfer. I'm going to clear this, ha? Lapit nang mag-end. So connect ulit tayo. So, ang formula natin ng heat transfer, 'di ba? Pag may ina kayo, IQ times Cmin times THI minus TCI. So gamitin niyo lang to calculate Q. Q yung hinahanap, ano? So 0.71. Yung Q natin is MCP delta T. So yun yung hinahanap. Cmin, yun yung sa water. Yung sa water is 2.79, ano? So this is ang unit niya ay kilojoules per second per kilogram. THI natin is 383, ano? Tapos TCI is 308. Yun. Tapos calculate nyo lang. You're supposed to get